Router ID is like the ID card of the device. Then the generated LSA will be associated with the router ID. So they cannot easily conflict. Router ID has a strict configuration format. It is an IP address configuration format, aka dotted decimal. It has nothing to do with IP address. It does not require a suffix mask. This is just a configuration format. How do we usually configure it when we do experiments? Typically, on each device, we up a loopback port. Up a loopback port on R1. In R2 this also up a loopback port. There is already a loopback port on R3. Is 3.3.3.3. R1 here is 1.1.1.1. R2 here is 2.2.2.2. Then I use the address of the loopback port as the router ID of the current device. When we experimented, R1 router ID is 1.1.1.1. R2 router ID is 2.2.2.2. R3 router ID is 3.3.3.3. It is convenient for you to do experiments. We usually have to configure the management address for the device in the project. We have to configure the loopback port address for the device. If it is configured with 192.168.255.1 24-bit mask, then R2 is 192.168.255.2. R3 is 192.168.255.3. There may be many devices in a network segment. Just run OSPF. We usually configure it the same as the loopback address. But we are on the project. It is usually not written as 1.1.1.1. Sometimes we plan based on the overall address. Still tend to write like this. That is, there is a dedicated network segment like this. Use these devices as loopback addresses and router IDs. This is a simple configuration principle of it. Now its configuration format is dotted decimal. But it's not an IP address. For router ID, it can be generated in two ways. Take a break for a while. The first is called artificial configuration. You can manually configure the router ID. We usually recommend this way, because you can manage it yourself. It doesn't matter if you don't configure. It can be automatically generated inside Cisco. If there is a loopback port, then select the one with the largest IP address as the router ID. If there is no loopback port, then select the router ID with the largest IP address of the physical interface. For example, now R3 has a loopback port on this device. Is 3.3.3.3. Now this has an interface address. Is 23.1.1.3. Suppose R3 is connected to R4. Then this interface is 34.1.1.3. Then if there is a loopback port on this device, if you have not configured router ID, then the device will use it as its own router ID. If there is no loopback port on the device, then the device will regard 34.1.1.3 as the router ID. The IP address with the largest physical interface will be selected. It's a rule in Cisco. And the router ID has a feature. As soon as it is determined, unless the device is reset, or OSPF process reset, otherwise it won't change. Now for router ID. OSPF is running between devices. The device is sending out LSAs. The device is receiving and synchronously maintaining its own routing table. Router ID cannot be easily modified. You can reset OSPF. Changed after reset. Okay. Let's go on. There are other key parameters. We'll also have a concept of regions. I just mentioned it to you. Have an area code. First of all you need to know OSPF itself is multi-area oriented, because it is aimed at medium and large network environments. So its overall support and scalability are very strong. It can support a lot of devices. Then when the number of devices reaches a certain number, we'll find out all devices in OSPF to exchange LSA with each other. Synchronize the overall LSDB. Now the LSDB in the 3 devices is this big. If targeting a single area within a range, we want it to have 50 devices, even 100 devices, 200 devices. If the OSPF protocol is running, the equipment is in a large environment to sync this bucket, then the bucket will become extra large. That is, in the whole database. It even needs to hold the LSA of hundreds of devices. Relatively speaking, its overall load will be relatively large. Equipment will be more difficult to handle, because the device has to calculate. It goes to any other core node in the entire network path. For example, now the data is going to this device. It is equivalent to a node in the network. This device is meant to perform calculations. If the number of devices is very large, the path calculated by each device will be very long and very complex. For equipment, it will have a higher load. Actually, there is no need for this. We're going to divide the area. For example, in the future you will find in the project, we are going to run OSPF. Then a certain piece of your business is placed in one area. Usually it's the core business. Will be placed in this position. There will be some other areas next to this area. This is the division rule. There is a zone 0 here. This is called the backbone area. This is an area that OSPF must have. Then the other zones can be zone 1, zone 2, and zone 3. All areas must be connected to the backbone area. There will be a device in the middle. This device is called ABR. It is a router at the border of the area. We only learn a single area in the NA stage. But everyone must first understand the concept of multi-region. The red circle I drew inside this area are some internal devices. Devices inside the region will only synchronize LSDB within one region. For example, between these devices, including this interface also, they go to synchronize an LSDB. Then, for region 3, these are the devices. Their interface. They go to sync LSDB. So about how the final regions interact with each other, you will learn in NP. At this stage, you only need to know that OSPF is multi-area. So, when we configure, must also specify the region. And for regions, let's go back to this picture and say, if you want to establish a relationship between R1 and R2, then the two interfaces must be in the same area, must be in the same region. This is a prerequisite for their data to be synchronized. If you take the IE test in the future, there will also be corresponding questions. Neighborhood cannot be established. The reason may be that the area code is inconsistent. OSPF is based on interface division. Assume this interface belongs to area 0. This interface also belongs to area 0. But the left interface of R1 can belong to area 1. It's okay. Because the division of OSPF areas is based on interfaces. We often don't say where the device R1 belongs to. Rather, it means that an interface